Hey pre-calc students, this is Mr. Mitchell here. We're going to look at graphing by transformations. This is section 1.6 and 1.7. So first we're going to talk about parent graphs. So anything can be a parent graph, and we look at different parent graphs throughout the whole course. But we're going to look at 5 parent graphs in this lesson. So some of these you should definitely know what they look like already. We're not going to spend a lot of time on them. Parent graph of x squared, it is a parabola. And it kind of looks like this. And like this. So that's a parabola. It's not a great sketch. I'm trying my best here on the Wacom board. This is the absolute value of x. The absolute value of x is a V shape. It goes through 0, 0, and it's a straight line. I'm trying my best to do a straight line here. And it goes this way. Okay, so that's another parent graph. We should know the shape of that. Okay, the square root of x, it looks like that. It's kind of like a half sideways parabola. You don't have this part of the parabola down here, so it's like a sideways parabola, but only the top half. So again, we need to know these parent graphs. If you use a calculator to graph them, that's fine, but we should be able to graph them without a calculator. Y equals x cubed is a cubic function. It looks like that. And then the cube root function, that's what that is, it's kind of sideways. It's kind of a sideways cubic function. So those are your 5 parent graphs that you should know how to graph. Okay? So now we're going to do things to them. We're going to transform them. That's why it's called transformations. So we're going to do a vertical translation. We're going to shift this graph up or down. How do I know it's up or down? Well, where is the number located? The number is outside. You might say, well, there's not even an inside. True, but okay, let's look at this one. Notice where the absolute value is. This plus 2 is outside. This minus 1 is outside. So our parent graph from up above is x squared. So this is the parent graph that we start with. We're going to take our parent graph, and then we're going to shift it down 4. Let's see if I can get rid. We're going to shift it down 1, 2, 3, 4. So here's what our graph looks like. So what do we call this? We call this a vertical translation down 4. So we can do abbreviations here. We don't need to write it out, but we definitely need to say what happened to the graph, especially when we get into combinations where multiple things happen. Right now, we're kind of in a bubble. Only one thing's happening to our graph. So what does this plus 2 do to the graph? Well, it's outside. That means it's going to do something up and down. It's adding, so you're going to move it up 2. Think about what your original parent graph looks like. The parent graph is a V. So then the V just moves up 2. So it's a vertical translation up 2. Just shifting the graph up 2. All right. And then we have our third graph here. Again, go back to the parent graph. Parent graph is a square root. So it kind of looks like this. So what does a minus 1 on the outside do? It's going to take it. It's going to shift it down 1. So there's kind of what our graph looks like. So it's a vertical translation down 1. Okay. Then we have our cubic function. It's x cubed. That's our parent graph. We need to take it and we need to shift it down 2. So you take your graph, you're going to shift it down 2. So it's going to look like that. It's a vertical translation down 2. Just classifying what is happening to our graph. And then this, it's a cubic function. It's going to move up 1, so it's going to look kind of like this. Normally it goes through here, so it's a vertical translation up 1. Now, the rule for vertical translation, this is a little confusing, but I have already interpreted it for you. If the number is on the outside, You go up if it's positive, you go down if it's negative. You do exactly what it tells you to do. Okay? Pretty cut and dry there. Well, now we're going to change it up a little bit. Now look, I said about things being on the outside. Look, notice every single one of these has something on the inside. You see with a parabola, that's the inside. Here's the absolute value. So we still need to think about what our parent graph looks like. You gotta know what the parent graph is. Parent graph here is a parabola. So my parabola, what's this minus 4 do? It does not shift it down 4. If it were this, y equals x squared minus 4, that shifts it down 4. That's not what that looks like. They look different. Inside -4, outside -4. Anytime you have something on the inside, you're doing something left and right. You're changing the graph left and right, horizontally. So anytime it's on the inside, you go left and right, you're going to go opposite. So it's a -4, you go right 1, 2, 3, 4. And then your parabola looks like that. Basically what you do, if you can't remember the opposite trick, set the inside part equal to 0. So that tells me I need to move it right 4. So this is a horizontal translation, right 4. I come to this, remember that this is the V graph, so normally it looks like a V here. It's on the inside. That means something left and right is happening. When you do inside stuff to an equation, that means it affects left and right. It's x plus 3, you got to go opposites. You got to go left 1, 2, 3, and then you make your V. And it's a horizontal translation, left 3. Square root function. So square root function is like half of a parabola sideways. It's on the inside, so you're going to affect it left and right. You're going to go right 1, and then draw your graph. So this is a horizontal translation. You can write out the word right or left. You can write out all the words if you prefer. Right 1. All right. Now we have our cubic function. This is on the inside, so it's going to affect it left and right. You're going to go left 2. So my graph looks like that. This is a horizontal translation, left 2. Cubic function, it's on the inside. You're going to move it left 5. 1, 2, 3, 4, 5. So this graph is going to look like that. Horizontal translation, left 5. All right. So let's take a look at what is next. I'm going to put this into another video, but what's next is, notice the difference. I need you to see the differences. You can't think that this is the same thing. This is multiplication. This was addition and subtraction. That's different. You're going to do something different to the graph. It does not affect it the same way. Okay, so we need to just be aware of that, and we need to identify it correctly. So stay tuned for part 2.